Hello, grade 8. Let's take more examples about the independent and dependent events, mutually and overlapping events. Here now, A, then B. Here we have a dependent events. If I choose, I have to choose two marbles, marble A, then marble B. For them here, we have two things. We have without replacement, selecting without replacement, and with replacement. Let's start now here without replacement. Without replacement means like I choose one of the marbles, or I select one of the marbles, but I didn't replace it. I keep it out of the bag. Let's see here how the probability will be. Let's have this example. You choose a marble at random from a bag containing 3 blue marbles. So here, and this is the bag, and we have 3 blue marbles. 1, 2, and 3. And we have 5 red marbles. 1, 2, 3, 4, and 5. And we have 2 green marbles. That's it here. So here now, as you see, we have here a lot of marbles. How many they are? They are 5 plus 3, 8 plus 2, 10. So we have here 10 marbles. I want now to take 2. To take or to select 2 marbles from the bag. Now, what is the probability that both of them are blue? So let's start now with the first one, both blue. Here, both blue, it's mean like it is the probability of blue times the probability of blue after the first blue. I mean like, now here, what is the probability of blue? How many blue marbles here we have? We have 3. So the probability will be 3 over the whole possible outcomes, which they are 10. So we have now 3 over 10 times. Without replacing means that I take one of the blue marbles, I put it now out of the bag because I already selected. So then here now, after I take this one, so how many marbles we have here left? We have 9 marbles. And then since we have now 9 marbles, so since we have here now 9 marbles, I want now to choose the second one, blue. Now, how many blue now we have here? We have only 2. So I have to say now 2 over 9. I will repeat. The probability now of choosing the first or selecting the first marble is blue. Is 3. We have 3 blues at the beginning over 10. Then after I take the first blue, I keep it now outside. So I have now here 2 blue only. So the probability now will be changed. The probability now will be 2 blue over the whole number, which they are 9, because I take one of them outside. So here the answer will be 6 over 90. Now let's solve number 2. In number 2 here, we have to find the probability of, just 1 second, let's place it back now. Now then here, we have number 2, we have to find the probability that both of them are red. Yeah, both of them now are red. How many red marbles here we have? We have 1, 2, 3, 4, 5. So the first case, we have 5 red marbles over 10. I select now the red. I put it now out of the bag. Outside. Okay. Then the second marble will selected will be red. Now how many red we have left? Look here, we have 1, 2, 3, and 4. So now we have 4 over how many marbles in all? They are 9. So the answer will be 20 over 90. Now, the third case here, just put it back. Let's put it now in the bag here. And then let's solve number 3. Number 3, what is the probability that the first one is the blue and the second one is the green? The first one is the blue. How many blue here we have? We have 3 blue over 10. And then the second one is the green. For the second one here, I choose, since I take the blue one outside, so then now I want to choose the green. But choosing the green didn't affect choosing the blue, because the number of greens here didn't depend on the number of blue. So here, what did we have now? We have 2 greens over. But after we put out, or we take out the blue, how many marbles now we have? We have 9. So now the answer will be 6 over 90. Now, number 4. The probability of red, then blue, will be probability of now will be what? What is the probability now of getting red? How many red marbles here we have? We have, let's count them, yalla. 1, 2, 3, 4, and 5. So how many red marbles we have? We have 5 over 10 times. I take one of the, or I choose, or I select one of the marbles red. I take it now outside the bag, out of the bag. Then here, 5 over 10. Then how many blue now we have? Here we have 3 now of blue. The number of the blue didn't depend on the number of the green. So we have 3 over. Now how many marbles here we have? Let's count them now. After we took the red, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here we have 9. So it will be 18 over 90. Now, number 5. The probability that it's a green, then red. Now, green, then red. What is the probability of the green? Here we have, how many one are green now? We have 1, 2. Over 10 times. How many one are red? We have 5. But over what now? Over 9. So they will be 10 over 90. Now, this here, if we have now the probability of red, then the green, shall we take the same answer? Let's see. So green, then red, without replacement, we have the probability as 10 over 90, or we can say 1 over 9. Now, red, how many reds here we have? 1, 2, 3, 4, and 5. over 10 times. How many green we have? We have 2 green over how many now we have, how many marbles after we take the red outside? How many marbles we have now? We have 9. So the answer will be 10 over 90. So yes, we will get the same answer. Now, number 6. The probability that both of them are green. Both of them are green means like what is the probability that the first marble will be selected as a that's the marble selected as a green? It's 2 over how many marbles we have? We have 10. Then after we took one of the marbles outside, then how many marbles now here? After that we have 1 only are left over. How many marbles now? We have 9. So it will be 2 over 90, or you can say 1 over 45. This is here the probability of the event A, then B without replacement. So an event A, then B without replacement is an example of an dependent event. Now the second thing here, that if we have now an, can say the same, but let's make this back here. Now the second one here, or the second thing is that if we have the probability of A, then B, but now without replacement. With replacement, sorry. The second one here, that if the probability of A, then B, now with replacement, like they are independent events. That if I choose the first one is my first marble blue, it didn't affect my second marble. So this is here will be now an independent events. Or if you have a question like you choose a marble at random from a bag containing 3 blue marbles, 5 red marbles, and 2 green, the same as the question before, but here you pick the second marble with replacing the first. And I choose the blue, then I replace it. Then I will take another one. Let's find now the probability with replacing. This case here, it's very easy. Let's start now with the case number 1. What is the probability that both of them are blue? Now the first one, I took the first one. Now look at them here. How many one are blue here we have? We have 3. So we have to say 3 over 10 times. I take it now. Then with replacing, so I replace it. Then I will choose now the second one, blue. So how many one are blue now? They are still 3 over 10. I didn't take any of the marbles outside. So the answer will be 9 over 100. The first one is blue and the second one is blue. And here with replacing, I take it, then I replace it. Number 2 now. Both of them are red. How many one are red here? We have 5 over 10. I choose the red. I take it outside, then I replace it. So since I replace it now, so we have still 5 over still 10, they are 10. So it will be 25 over 100. Or you can say 1 over 4. Now, number 3. Probability of blue then green. Yeah. What is the probability that the first one is blue? We have 1, 2, 3. So we have 3 over 10 times. The second one is green. We have 2 over 10. 3 over 10, then 2 over 10. I didn't take it outside. I just take it and then replace it. So then the answer will be 6 over 100. Okay, say 3 over 50. Number 4 now. The probability of blue, no, sorry, red then blue. Will be. What is the probability of getting red first? We have 5 over 10 times blue. How many one are blue? 3 over 10. So which will be 15 over 100. I didn't here, just I select it, then I replace it. Number 5 now. Number 5 here, the probability that the first chosen is green and the second one is red. The first one is green, it's 2 over 10. And the second one is red. How many one are red? We have 1, 2, 3, 4, and 5. So 5 over 10, which is 10 over 100 or 1 over 10. The last one, the probability that both of them are green. Both of them are green without with replacing, sorry, they will be 2 over 10 times 2 over 10, which will be 4 over 100 or 1 over 25. Now here let's distinguish between two things here. That's if I told you now what is the probability of choosing a blue, or just a second, sorry, of choosing both red with replacing and probability of both red without replacing or without replacement. Now the first case, both red with replacing, and I choose the first one is red, so I have 5 over 10. After I select it, I take it one out of the bag, then I replace it. I would replacing, so I replace it. So how many one are red? They are still 5 and they are still 10. So we have them as 25 over 100. Now the second case, both are red, but without replacing. So the first case here, how many marbles are red? We have 5 over 10. But after without replacing that's mean I will take the red outside the bag and keep it outside. So after I take the red out of the bag, here how many one are red now? We have 4 red times. How many one here are left? They are 9. So they are 20 over 90. So here, the first case here, we have to say this is independent. And this case here, it will be dependent. The first case here, they are when I choose both of the second one is red, it didn't depend that the first one is red or blue. But the second case, the second one, when it is red, it depends on the first one, if it is red or no. That's why here it's dependent. This is here the difference between replacing and non-replacing events. Now, Let's take now another example. Suppose you roll a number cube and spin a spinner with 4 equal size sections labeled 1, 2, 3, and 4. So here, what did you have? You have a number cube, so the sample space for it will be 1, 2, 3, 4, 5, and 6. And for the spinner, this is for the spinner with 4 equal sized sections labeled with 1, 2, 3, and 4. So here, the first case for the number cube. And the second one here for the spinner. Now, what is the probability? Now, focus with me here. What is the probability that you roll a prime number on the, you roll a prime number and you spin a prime number? Now, what did you see here? You see word and. Word and, it's mean they are dependent or independent. Since we have here two different things, number cube and a spinner, and if I choose number from, like, as we say, the blue and the red number cube, here we have number cube and here we have the spinner. So if I choose a number 1 on the number cube, doesn't depend if I choose number 1 on the spinner. Now the first case here, what is the probability? So this case here will be independent event. Now the first one is the probability of roll prime number times, and it's been multiplied, probability of choosing or spin prime. Now rolling a prime, it's mean I'm going to the number cube. Here roll, and here you spin the spinner. So rolling here. Now what is the prime number? The prime numbers, let's remember, what are the prime numbers? The prime numbers are 2, 3, and 5. The numbers that they didn't divide on any other number except itself. And be careful, number 1 is not a prime number. So then, rolling a prime number, here, the prime numbers are 2, 3, and 5. So how many, what is the probability of if I roll a prime number on the number cube? You have 3/6 times, what is the probability that I spin a prime number? And let's go to the spinner now. How many prime numbers here we have? We have 2 numbers only. Over how many outcomes? We have 4 outcomes only. So the answer will be 6/24 or 1/4. So this is here. Since we see word and, this is mean you have to think if it is independent or dependent. Don't think about mutually or not mutually exclusive. Now, this example here. The tables below shows the distribution of a letter tiles in a board game. Players select a letter tile at random. Find each probability of choosing a letter A or choosing a letter I or U. Now, let's add the first case. Probability of A, this is here an simple event. This is an event from, or this is a probability of one event. So probability of choosing letter A, we have 4 over what? Let's add all of the numbers. 4 plus 7, 11, plus 3, 14, plus 4, 18, plus 2, 20. So it will be 4/20, can say 1/5. Now, of I or U. lessons. Here you see word or. This means mutually or overlapping. Then I or B. So I think now, before solving it, can the letter B I, يعني can the letter B and letter I and letter U at the same time? No, it cannot. So this will be now here a mutually exclusive, because the letter cannot be I and U at the same time. So it will be the probability of I plus the probability of U. The probability of I is 3/20 plus the probability of U is 2/20. So it will be 5/20, or if you simplify it, it will be 1/4. Now, if as an example here, if we add here this one, and that like or no, let's take another example. Here, you have now sample space contains now a spinner that has 1, 2, 3, 4, 5, 6, 7, and 8. It has 8 is equal size from 1 to 8. Now, what is the probability of getting odd or greater than 5? Probability of prime or odd. Probability of even or prime. The first case now, odd or greater than 5. Now, when you see word or, this is mean mutually or overlapping. Now, the first one, odd or greater than 5. The first question you have to ask yourself, you have now to decide if it's mutually or overlapping. Is there a number that can be odd and greater than 5? Think about it. Greater than 5 and odd? Yes, there will be. So this is an overlapping. So what you have to do here? You have to say it is the probability of odd plus the probability of greater than 5 minus the probability of odd and greater than 5. Now, the probability of getting odd, how many numbers are odd here? How many numbers here are odd? We have odd. We have 1, 3, 5, 7. Well, so we have here 4 numbers over 8. Plus, how many numbers are greater than 5? Greater than 5, they are 6 or 7 or 8. So 3 numbers. Now, how many numbers are greater than 5 and odd? We say that it's only 7, so we have 1/8. So the answer will be 6/8 or 3/4. The second case now. the probability of prime or odd. Now here you have to ask yourself, is there a number that is a prime and odd at the same time? Prime and odd. Yes, there is. So here, probability of prime plus the probability of odd minus the probability of prime and odd. The first case now, the probability that the numbers are prime. How are? We have 1, no, 1 no. We have 2, 3, 5, and 7. These are now the prime numbers, 2, 3, 5, and 7. So we have now 4 numbers over 8. Now plus, how many numbers now are odd? So here, the prime numbers are 2, 3, 5, and 7. The odd numbers are 1, 3, 5, and 7. So they are 4 numbers. Now, how many numbers are prime and odd at the same time? Yeah, prime and odd. We have 5, we have 7, and we have 3. So we have 3 numbers are prime and odd. So we have 4 plus 4 is 8 minus 3. So they will be 5 over 8. Now the last one. What is the probability that it is even or prime? Probability of even plus the probability of prime minus even and prime. How many numbers are even now? We have 2, 4, 6, and 8. So we have 4 numbers over 8. Plus, how many numbers are prime? We have 2, 5, 7, and 9. So we have 4. Now, how many numbers are? So let's draw the circle here for the even number. We have 2, 4, 6, and 8. Then, here now, how many numbers are even and prime at the same time? Only one number, which is number 2. So we have the answer now as 7 over 8. Another example now. What is the probability of choosing a prime number or greater than greater than 7? Now, here, probability of prime number. So first, plus probability of greater than 7 minus probability of prime and greater than 7. Yeah. Now, probability of prime. How many numbers are prime? We say 2, 3, 5, and 7. So we have 4 numbers are prime. How many numbers are greater than 7? Only 8. So, prime, we have 2, 3, 5, and 7. Greater than 7, they are 8. Now, is there a number here? Or is there an outcome as a common here? No. So we will say that there is no number that is prime and greater than 7. So this question here will be mutually exclusive. So the answer will be 5/8. So, and dependent or independent, or mutually or overlapping. Thank you.